welcome to Chapter 5 review for the honors class. I'm going to go kind of slow, but if you want, you can slow this video down if you need to, or rewind and watch part over again. So, first one, the equation log of b, log base b of x equals y can be written in the exponential form b to the y equals x. So what I do is I look at this and say, well, what's the base here? It's base b, the power is alone, so it's b to the y, and it equals x, so that's exactly what that says, so the answer is true. Now, I'm writing with my mouse, so please forgive my sloppy handwriting. The domain of the function, e to the x, is from 0 to infinity. Well, if you graph this, you would notice that the domain of the exponential function is all reals. It's not limited from 0 to infinity. So this one is false. Log base 5 of 13 can be rewritten as log base 13 over log base 5. That is true because what's happening here is that's the change of base formula. So if you don't have a calculator that you can put log base 5 in, you could do log of 10 divided by log of 13 divided by log of 5 and get the same answer. So that one is true. Horizontal asymptote of the graph, e to the x minus 1 plus 4 is y equals 1. Well, the horizontal asymptote of the exponential function would be y equals 0 for the parent function, but it's shifted up 4 for this one. So it would be y equals 4, not y equals 1. So that one is false. This one, I'm just going to change it to exponential form because that makes sense in my mind. So it would be 2 to the x, but then we're told that x is 3. So it's 2 to the third equals 1/8. And that is not true. So this is not true, the whole thing. If this were a negative 3, then it would be equal, but because it's a positive 3, it is not equal. The expressions, log a to the third plus log b to the fourth minus log c squared is equivalent to. Now this one's going to be tricking you because you're like, oh yeah, the plus means to multiply these together, and the minus means to divide them, but we do not write them with log over log. So that part of it makes it false. And this one, log base 17, or log of 17 divided by log of 3, if you remember up in here, that would mean log base 3 of 17, not subtraction. So that, again, is written wrong. You don't write log over log. Number 1, we're looking to see if it's an exponential growth or decay. I notice the negative in the exponent, so that makes this one a decay. And then if you graph this, it'd be kind of hard to see the y-intercept because it's not on the graph. But if you turn your table, or turn your graph into a table, you would see that when x is 0, y is 500, so that's the y-intercept. 0, 500. Number 2, because the 2x is a positive, this is then going to be a growth function. It's going to grow, can't spell, and it also crosses at the 0, 3. So just generally, the number in front of the e tells you the y-intercept. That's only if there's nothing added or subtracted at the end. Next one, I'm going to start with the domain and the range because once I have those two figured out, then I can write the rest. So the domain of this exponential function, the e is being flipped The function's being reflected across the y-axis, so maybe I'll just make a little note of that so I can get that part of the way. So it's reflected on the y-axis. And then also it's being shifted up 7. The domain of an exponential function is all reals. And moving it around doesn't change the domain. So the domain is still all reals. The range of the parent function would have gone from 0 to infinity, but because this has been shifted up 1, now it goes from 7 to infinity, which also tells me that the asymptote, instead of being y equals 0, is now y equals 7. It's a horizontal one because the range is what's changed. The range is limited. And also the range tells you the y value, so it tells you what it starts at. Okay, next one. I'm going to start with the domain again. Domain of this exponential function is still all reals. And the range, I'm going to look at how this has been shifted. Okay, this one, because of that negative out in front, is being reflected across the x-axis. So notice in number 3, it was reflected across the y-axis when the x was negative. But this one, because the whole thing is negative, or the negative is out in front, it's being reflected across the x-axis. And then also, it's being shifted up 1 unit. So the domain is all reals. The range, because it's being reflected across the x-axis, it is now going from negative infinity up to positive 1. And the y equals 1 is the horizontal intercept on that, the horizontal asymptote. Okay, next one. This one, that 3 right there, gives it a stretch. And it's just going to make the graph look all stretched out and kind of funky looking. The negative 5 shifts it down 5. The domain is all real because this is an exponential function. And the range, because it's been shifted down 5, now goes from negative 5 to infinity. That's an infinity sign. And the asymptote is only equals negative 5. Number 6, so what we're doing is we're writing the equation for g. So we're just going to write g of x. And we're going to start out with this exponential function, e of x. But the first thing, it's a reflection in the y-axis. So that makes the x negative. And then translation 2 units down, that makes this minus 2. This one, same thing, we're going to start out with the parent function of e to the x. But this one is a reflection in the x-axis, so the negative goes out in front. And then 5 units left means that we're going to add 5 to the x. So it's to the power of x plus 5. All right, John invests $5,000 in interest 1% compounded continuously. Because it's compounded continuously, then we can use this equation. A equals PE to the RT. A represents how much money he's going to end up with, and that's what we don't know, so we're just going to keep that. The principal started out at $5,000. E, the rate is 0.01 times 30. Then we just grab a calculator and we put that in. 5,000 times e to the 0.01 times 30. The place where students mess up is they forget to times those two together. And the answer is in dollars. about $6,749.29. Number 9, we are going to change it to logarithmic form. The base is 2, so I write log base 2 of 32 equals the power, which is 5. Remember, power stands alone. This one is, the base is 10, so I write log base 10, but I don't even need to write base 10 of 100 equals 2. This one, the base is e, so I write log base e, which is ln. ln of 20.0855 equals 3. I'm just doing the opposite. So this time I start with the base of 6. 6 to the third equals 216. This one has a base of e. So this is e to the 0.693 equals 2. This one has a base of 1/2. So it's 1/2 to the third equals 8. Oh, that's to the negative third. Okay, so now we're going to find the inverses. And how we do that is we first replace the y and the x. So this is y, so I'm going to replace it with x equals the natural log of y plus 4. And now I'm trying to get that y alone. So first thing I would do is to get rid of the ln. I raise everything to the power of e. And then that cancels it out. So I end up with e to the x equals y plus 4. Now, when I minus a 4 from both sides, I end up with y equals, I'm going to put the y equals first because I like that, e to the x minus 4. Same thing over here. We're going to replace this with an x equals e to the y minus 2. This time, to get rid of the e, I have to take the natural log of both sides. So those cancel out, and I just get the natural log of x equals y minus 2. To get the y alone, I'm just going to add a 2 to both sides. So y, and it's all alone, y equals natural log of x plus 2. And that would be your final answer. Simplifying the following. So in order to simplify, I've got to have things cancel out. And we have log base 4 of 64. Well, that can't cancel out. But if I can get 64 in terms of a 4, then it will cancel out. So I'm going to rewrite this as log base 4 of 4 to what power? Well, I know that 4 to the third power is 64, because 4 times 4 is 16, times 4 is 64. So that's a 3, oops, a 3. And then we still multiply it by the x, because the x was already there. Now the log base 4 and the 4 cancels out. You are just left with 3x, and that's your answer. This one is already simplified as far as being able to cancel out. So the 6 and the log base 6 cancel out. Your answer is just x minus 3. The log of 1 doesn't matter what the base is. Like if you just type this into the calculator using any base, it's just 0. And this one, the log base b of any b, that just cancels each other out to be equal 1. This one I've got to change. So 1 over 25 If I write that in terms of a power of